Anthropic's Claude Opus 4.7 recently built a complete text-to-speech engine in Rust. It executed the entire project from scratch with zero human supervision. During this single run, the model autonomously generated the underlying neural model, wrote the SIMD kernels to optimize processing speed, and built a functional browser demo to interact with the system. It then devised its own method to verify the work. It independently fed its generated audio through a separate speech recognizer to confirm the output matched the original Python reference codebase. Delivering an end-to-end verified architecture of this complexity typically requires months of dedicated senior-level engineering. This benchmark establishes a break from standard interactive AI. We are now looking at the viability of sustained, autonomous engineering execution, an architecture that operates without a human in the loop. The standard approach to generative AI relies on one-to-one conversational workflows. A user prompts, the model replies, and the cycle repeats. Opus 4.7 forces a pivot toward parallel, asynchronous agents. Anthropic intentionally optimized this model's architecture for rigorous consistency over long, multi-step runs, deliberately moving away from prioritizing fast, single-turn chat latency. They achieved this through three specific mechanical upgrades: deep architectural loop resistance, a new compute scaling parameter, and a reworked token economy. Mastering these three mechanics is a prerequisite for developers who want to transition their pipelines from supervised copilots to fully autonomous background workers. This animated diagram compares two agent architectures to illustrate the most critical failure mode in highly agentic workflows, the infinite tool call loop, triggered by dissonant data traps. When legacy models hit a node where data is missing, they attempt to generate plausible but ultimately incorrect fallbacks. This forces the system into a rapid cycle of repeated, failing tool calls, consuming compute resources and blocking the pipeline. Opus 4.7 incorporates graceful error recovery. When it encounters the exact same missing data node, it recognizes the trap immediately, halts execution, and explicitly reports the missing information to trigger a safe exit. Production data from GenSpark highlights the impact of this architecture. In their testing, indefinite loops previously broke 1 out of every 18 queries. Opus 4.7 eliminated these failures entirely. By resisting these indefinite loops, a brittle AI agent becomes a reliable, enterprise-grade production tool capable of unsupervised execution. To govern how the model processes complex logic, Anthropic introduced a new compute control mechanism, the extra high or X-high effort parameter. Enabling X-high forces the model to allocate significantly more compute toward internal reasoning, specifically during the later turns of long-running, multi-step tasks. This sustained period of deep reasoning prevents the model from dropping context or giving up when a problem becomes difficult halfway through execution. Internal evaluations from Notion Agent quantify this capability. In their testing, Opus 4.7 delivered a 14% improvement in complex task resolution, while simultaneously reducing tool errors by 2/3. This capacity for sustained focus also powers the new /ultra review command inside Claude Code. The ultra review feature uses the model's sustained focus to isolate architectural bugs and design issues that surface-level syntax checks typically overlook. The X-high parameter allows developers to intentionally trade raw speed for rigorous validation, deploying the model as a senior technical reviewer rather than a fast autocompleter. Sustained autonomy requires a heavier and significantly more expensive token economy. Opus 4.7 implements an updated tokenizer. While this allows the model to process text logic more efficiently, it directly inflates raw input counts. This side-by-side bar chart illustrates the scaling math. Identical code inputs that registered as a 1.0 baseline on Opus 4.6 will now map to between 1.0 and 1.35 times more tokens on Opus 4.7. The X-high parameter acts as a compounding variable. Because the model spends more time thinking to resolve logic, it generates a massive increase in output tokens. Compounding this economic shift is a strict behavioral change. Opus 4.7 enforces literal instruction adherence. It no longer relies on implied context to fill in the blanks. Legacy system prompts written for models that loosely interpreted instructions will predictably break pipelines or produce highly unexpected results. To prevent runaway API costs during unmonitored agentic runs, Anthropic introduced API cask budgets, allowing developers to set hard caps on token spend. Treating Opus 4.7 as a frictionless plug-and-play upgrade will result in bloated infrastructure costs. Developers must rewrite their system prompts and enforce strict task budgets to safely scale the model. Anthropic also placed a deliberate, hard boundary on Opus 4.7's autonomy. This restriction is part of Project Glasswing, Anthropic's methodology for safely deploying models that possess high-risk capabilities. Despite its state-of-the-art software engineering skills, Opus 4.7's offensive cybersecurity capabilities were intentionally throttled during the training phase. Releasing a highly capable but strictly contained model allows security engineers to test and refine automated cyber safeguards in real-world production environments without introducing systemic risk. This data will inform the eventual release of the upcoming Mythos preview model, which will unlock full cyber capabilities exclusively for vetted security professionals. By decoupling specific domain expertise, Anthropic can test and refine security protocols on autonomous infrastructure before applying them to more powerful models. Adopting Opus 4.7 requires software teams to execute a ground-up redesign of their existing LLM orchestration pipelines. Engineers must aggressively strip legacy fallback scaffolding and meaningless wrapper functions from their codebases, because the model is now capable of self-correcting natively. Despite the increase in raw token volume, the baseline API pricing structure remains locked at $5 per million input tokens and $25 per million output tokens. The combination of literal instruction following, X-high logic scaling, and native loop resistance significantly raises the ceiling on what asynchronous workflow automation can achieve. Working with Opus 4.7 moves the workflow beyond human-supervised copilot prompts and into the architecture of the autonomous background worker.